Yes, this is question number 63 on stoichiometry, and it goes like this. If 750 milligram of CaCO3 is added to 20 ml of 0.5 molar HCl, what mass of CO2 is produced? Now let me show you how to solve this question. First off, you ensure that your equation of reaction is balanced, and in this case, is it? Well, calcium is 1 here and 1 here. Chlorine is 2, and here is 2. Hydrogen is 2 here. Here is 2, and our oxygen is 3. And here is 2 plus 1, 3. So it's balanced. That's usually the first thing to do. So after that, we'll then look at what we have. CaCO3 and HCl. And then we have our products. CaCl2, H2O, CO2. Now we can see here that 750 milligram of CO3 was added to 20 ml of 0.5 molar HCl. Let's figure out what the moles is, okay? First off, if you want to get the moles of this one, that's your calcium carbonate, you need to do mass divided by molar mass. The mass is given to you here as 750 milligrams. You have to convert that to grams. So that's why I'm going to do this. That would convert it to grams. And then that will be mass, right? If I divide the mass by the molar mass of calcium carbonate, which is about 100 grams more, it means that what I'm solving here is the moles. That's the moles of CaCO3. Does this make sense to you? Mass divided by molar mass. Yes. So that, we'll keep that aside. Or let's just solve it anyway. So that will give us 0.0075 moles. Right, now let's look at the HCl world. 20 ml of 0.5 molar. Can we figure out the number of moles there? Number of moles should be mass divided by molar mass. We know that. But then concentration is number of moles divided by volume. So that means that moles is actually concentration times volume. And that's what we're going to apply here. So the moles of my HCl will be the concentration, 0.5, multiplied by the volume, 20. But I have to divide that by 1000 for unit consistency. The 0.5 molar there is moles divided by liter. That's molar, mole per liter. So I have to have my volume in liters, so it will all make sense. That's why I had to divide by 1000 to convert mil to liters. So when you work that out, you have 0.01 moles, and that's the mole of HCl. This question is asking us to get the mass of CO2 that will be produced. Okay, but we have to compare this CO2 with either HCl or the other one. Okay, one of them should be right and the other one should be wrong. How do we know? Limiting reagent. Is this all making sense to you now? So, what's the limiting reagent we're dealing with here? Is it CaCO3 or is it HCl? To know the limiting reagent, we just have to get our number of moles in hand, and then we'll divide it by the coefficient here. We'll do the same thing here. This divided by this guy. And let's figure out what that will be. So 0.0075 divided by 1 will not change. It will still be 0.0075 for CaCO3. And the other one, which is 0.01 divided by 2, would give me 0.005. It doesn't have a unit because I'm dividing moles by moles. So 0.005 and 0.0075, that's what I'm comparing, 0.0075. This is for CaCO3 and this is for HCl. See what I'm doing here in this green ink? You don't have to show it, you do it on a scrap paper. Right, so 0.0075 is for CaCO3 and our HCl is 0.005, which is smaller. It is 0.005. That is smaller than 0.0075. Therefore, our HCl is the limiting reagent. You see, it might not be so obvious here because this is like 0.0075 and this is 0.01. Okay, so you don't judge by the number of moles. You judge by this ratio. Okay, so go ahead and divide it by the stoichiometric coefficient, then get the ratio, then judge. So yeah, we're judging here after listening, and our answer is that HCl is our limiting reagent. Right, so we need to compare HCl and CO2 to solve this question correctly. If you compare CaCO3 and CO2 to give you the number of the mass of CO2 produced, yes, that would be a way. You can also do it like that. It's just that that's the wrong way and you get the wrong answer. So it has to be HCl, okay? So you'll always be right. So comparing HCl and CO2, we can see from the equation that 2 moles of HCl produces 1 mole of CO2. Therefore, this 0.001 mole of HCl that I was given in the question, 0.001 mole of HCl, would produce the amount of CO2 there. That's just going to be divided by 2. So our x here becomes 0.001 divided by 0.01 rather, divided by 2, and that gives us 0.005. That is the number of moles of CO2 that will be formed. Now, since they asked us to get the mass of CO2 that will be formed, we just need to say that mass. Returning over to the second page. That is good. Moles times molar mass, right? The number of moles of CO2 formed, we've established that 0.0075. 0.005, I mean. And then we'll multiply that by the molar mass of CO2. What's the molar mass of CO2? Then do it gradually. 12 plus 2 times 16. You get 44 at the end of the day. And then when you do that multiplication by 44, you'll get 0.22 grams of CO2, and that is the answer to the question. So how was it for you? This has been 8 minutes so far. So if you were patient up to this point, it means that you should have gotten this to a large extent. However, have any questions, just drop them in the comments and we shall be able to attend to you. Alright, so like this video, you have done a good job staying up to this point. So that's very nice. It means that it's all making sense to you and I'm very happy about that. You can like this video and also share with your friends, okay? And I'll see you on the next question, which should be 64. Bye.